Hello guys, in previous video we have seen topic equivalent diameter, and today in this video we will solve the numerical based on that same concept. So one numerical we have taken as a rectangular duct section cross section of 500 mm multiplied by 300 mm size carries the 75 meter cube per minute of air having density of 1.15 meter kg per meter cube. Determine the equivalent diameter of the circular duct if the quantity of air carried in the both cases is same and if the velocity of air in the both cases is same. So similar concept we have seen in our previous video. So you can find that video in description box. Now you can now here we have to simple put the formula here and we have to find the equivalent diameter of the circular duct. And here some values are given. Let's suppose friction factor is given is 0.01 for the sheet metal, and for the pressure loss per 100 meter we have to find pressure loss per 100 meter of length of duct. So now solving the numerical, where small a is 500 mm and small b is 350 mm and q is 75 meter cube per minute, and rho a is equals to 1.15 kg per meter cube, and friction factor is 0.01 and length is 100 meter. Now equivalent first case is for the same quantity. So equivalent diameter of circular duct if the quantity of air carried in both the cases is same. Then then we have formula d is equals to 1.25265 multiplied by a cube b cube upon a plus b raised to 1 by 5. So just we have to put the value of small a and small b here. So we will get the value of capital D, which is diameter, equivalent diameter of circular duct. We get as 0.46 meter. For the second case, equivalent diameter of circular duct if the velocity of air in the both cases is same. Now formula is D is equals to 2ab upon a plus b. We put value of a and b here. We will get D as 0.41 meter. Now second sub question was to find the pressure loss. We know that the velocity of air passing through the duct V is given as Q upon A. Putting the value of Q and area, we will get value of V as 7.143 meters per second and hydraulic mean depth as A upon P. So we will get M is equals to 0.103 meter. For the pressure loss, PF is equals to FL rho A upon rho AV square upon 2M. So after the putting all the values here, we will get friction loss as 29 mm of water. So here we get the value, basically we get value into 84.8 Newton per meter square. So after dividing into value of G divided by value of G, we will get into mm of water. The final value is 29 mm of water. So this is the pressure loss in the duct. So that was that numerical, and our next numerical is if a duct of 2 meter by 1 meter size carrying the conditioned air runs in a straight line for a 50 meter from the supply fan, it divides into two parts, each of 80 meter long and 2 meter by 1 meter in cross section, as shown in figure. Its cross section is given and its length are given. So if the quantity of air discharge air at C is 1600 meter cube per minute, calculate the quantity discharge at D and the static pressure at the fan outlet A, and also calculate the duct friction loss in Newton per meter square, taking the value of friction factor as 0.005. Friction factor is given here. So in the below diagram we can see the cross section of the duct. There are three there is a main duct from the fan, and then there are two subsections given as A is equals to 2 meter, B is equals to 1 meter. Its cross section is given. Length of first branch is 50 meter. length of second branch is 80 meter, length of third branch is all again 80 meter. Q3 is equals to 1600 meter cube per minute. Q3 is a discharge of air in third branch and friction factor is given as 0.005. Now quantity of air discharge at D. We have to find quantity of air discharge at D. D is the outer section at the end of third branch. Now cross-sectional area of duct AB, BD and BC. So we have all the cross-section are same given as 2 meter square. Then velocity of air in a duct BC. So large duct it is BC. Here large duct is BC and we are having the value of Q here and also we are having cross section area, so we will get the velocity here first. So velocity at duct BC is we get like 13.33 meter per second. We know that velocity pressure PB is equal to V square upon 2 into rho A. So in this case we get the value as 0.6 V square Newton per meter square. Taking rho A as 1.2 because we are taking air as a standard air. Now velocity pressure in duct BC. So PV3 is equals to 0.3 0.6 V square V3 square. Now we are having value of V3, then we have to put here and we will get value of PV3 as 106.6 Newton per meter square. So we now got the velocity pressure in the duct BC. Now we have to calculate for the other. Since each duct is having same cross section, therefore hydraulic mean depth is same. So hydraulic mean depth will be same for all the cases and all the branches, which is 1 by 3. We are getting factor as 1 by 3. Now the pressure loss due to friction in a duct BC is PF3 is equals to FL3 upon M3 into PV3. So we are having value of PV3. So PF is 128 Newton per meter square. So we got PF3 value 128 Newton per meter square. Then the total pressure at B is PF3 plus PV3. So 128 plus 106.6 which is 234.6 Newton per meter square. So PV2 is velocity pressure at the duct BD and the V2 is velocity in duct BD. We know that the pressure loss due to friction in duct BD, PF2 is equals to FL2 upon M2 PV2. Now we are having value of F, L, M and we don't have value of PV2. Now we will get equation as 1.2 PV2 Newton per meter square. From the equation 1 and 2, we are having the PV2 is equals to 234.6 upon 1.2 which is 106.6 Newton per meter square. We got the value of PV2 and putting the equation we will get easily value of V. So velocity we get at 13.33 meter per second. We know that the quantity of air discharge at D is Q2 is equals to A2 V2. By the value of Q, by the value of A and V, we get the value of Q discharge at D, which is 26.66 meter cube per second. Multiply by 60, we get 1066 meter cube per minute. Now, our next question was to solve the for static pressure at the fan outlet. Now, we know that the quantity of air flowing through the duct AB, Q is equals to Q2 plus Q3. Total quantity is 3200 meter cube per minute. Now, velocity of air in the duct AB is V1 is equals to Q1 upon A1, which is 26.67 meter per second. Then velocity pressure in the duct AB, PV1 is equals to 0.6 into V1 square is 427 Newton per meter square. Now pressure loss we can get by the formula PF1 is equals to L1 upon M1 multiplied by PV1. Here 0.005 multiplied by 50 upon 1 by 3. After the putting the value, we get the value as 320 Newton per meter square. In this way, we get the value of pressure loss. Then the total pressure of fan outlet is total pressure at B plus pressure loss in the first section. Then adding the both the values, we get total pressure which is 554.6 Newton per meter square. Then which is And then we have to find static pressure of fan outlet. PSA is equals to PTA minus PV1. So total pressure, we have to subtract dynamic pressure from the total pressure. So we get static pressure at fan outlet, which is 554.6 minus 427, that is 127.6 Newton per meter square. In this way, we can solve the numerical based on the friction factor, friction loss, and velocity. So in the next numerical, we will see the method of duct design and the numerical based on it. So that's all for today. Thank you.